Hey fam, it's your boy, Mr. Wishart, your math teacher. Anyway, this is the review for your transformations quiz. We're going to cover the first three transformations. We're going to go down for CMAS. This is what I did beforehand. Anyway, got a couple definitions we want to start out with. Congruent just means same shape, same size. Another way to think about it is each matching side is like the same length, and each angle or each vertex has the same angle measure. Right, and if you kind of combine those two together, those concepts, then you get one shape being congruent to each other, or one shape being congruent to another shape. Now, translation is when you move, shift, or slide a shape, changing its position. Okay, another way to think about it is each point that makes up the shape move the same distance and direction, right? So, for instance, if we're translating 1 unit left and 5 units down, we're taking each point, we're going 1 left and 5 down, and if we do that with each shape, then we're going to have two shapes that are congruent to each other, okay? Because each point will have moved in the same distance in the same direction. So start with R, we go 1 left and then count 5 down. 1, 2, 3, 4, 5. We'll label that as R prime. That's what it means when it says label the image with prime notation. Primal notation, cool. 1, 1, 2, 3, 4, 5 for S prime. T does the same thing. 1 left and then 1, 2, 3, 4, 5. And if we did it the same for each point, then when we connect our lines, we should be able to see that each kind of side matches to the corresponding side on the other shape, and then each point or each vertex has the same angle measurement as well. Yeah, so I kind of look at those two shapes, ST matched S prime T prime, and so on, right? They look congruent to me, so it looks like we're good. Okay. Yeah. So now we're kind of working backwards. We have a transformation that's already happened. We have to figure out what transformation was, and kind of in which direction and distance each point moved. So we can just kind of go point to point. I'll go from F to F prime. I know that this is the image, right? And this is the pre-image. I know that because this shape has the prime notation on it, those little apostrophes, right? And you can see that I made them on my new shape right here. So it's kind of the same concept, just in reverse because it's already happened. So if I go from F to F prime, I can see that we went right 2 boxes and then up 2 boxes. So you can write this 2 different ways. You can say right 2 up 2. You can even say 2 right 2 up, doesn't matter. Or you could say X plus 2, Y plus 2, like that. 2 different ways to write it. Either way really will work. I'm gonna have some coffee. Put some pumpkin spice syrup in there. That was kind of a bad idea, guys. Okay. So a reflection is when you mirror or flip a shape. Okay. Over something called a line of reflection. Okay. And so you'll have lines of reflection can be x-axes, they can be y-axes, they can be vertical lines, like this would be x equals 3, or y equals -2. You'll also have diagonal reflections, but I don't think you'll actually see those till sophomore year, maybe freshman year. I'm not sure when you guys do transformations in the curriculum, whether it's freshman year or sophomore year. But anyway, we're looking for this one. I'm just going to test you on axes rather than vertical lines, and we didn't even talk about diagonal ones, so don't worry about that. But I'm going over the y-axis, or sorry, the x-axis. Let me get a highlighter here. So we're going over the x-axis. It's kind of cut off right there, but that's the x-axis right there. I mean, at this point, you really shouldn't need it labeled to tell which one is the x-axis. And the idea with reflections is that you count how far away each point is from that line of reflection, and then you count on the other side that same distance. So m is 1 box away, so then m prime will be 1 box away. That becomes m prime. L is 5 away. It's also kind of on the outer edge here, so I kind of just know that it's going to match that. And then K is 1 away, or sorry, 1 away from the edge or 4 away from that line of reflection, right? So 1, 2, 3, 4, and we count that same distance on the other side. 1, 2, 3, 4, K prime. And we do the same thing that we did with our translation. We connect our points, and if we did it correctly, then we should have a congruent image that matches to the pre-image. Looks good to me. Just kind of eyeballing it, looks good. So yeah, that's the reflection. And then for reflection that's already happened, you basically just have to tell which axes or which line it reflected over, right? So kind of one way to do that is to look at 2 points, right? If you can't just look at it automatically, then you can think about it this way, right? If I have 2 matching points, I have S and S prime. I can see that they're 1, 2, 3, 4 boxes away from each other. And if I take that 4 and I divide it in 2, I know that that's 2. So then I can count 2 boxes in here and then 2 boxes in, and they kind of meet at that point. And then that's my line because T is 1 away, T prime is 1 away, right? So they kind of meet in the middle. And so then I would draw a line between those 2 points. And that's the line. I mean, you don't even need it. I'm not even going to do it because you just don't worry about drawing that line of reflection. You can just know that it's the y-axis, right? So the rule is the shape, there was a reflection over the y-axis, right? Simple as that. Like if I took a look at this one and it had already been done, I'd be like, oh, well, I know M and M prime match. They're 2 away. Half of 2 is 1. So I would put a point right there. K and K prime are 8 away from each other. Half is 4. So I count 4 and I've got 2 points right there. And I can do that line. And I can see that it's the the x-axis right there. So there you go. Now we've got a rotation. This is a little more complicated. So we're going to go 90 degrees clockwise about the origin. I've got these right here. Clockwise goes this way. Counterclockwise goes this way. It's kind of a little cheat sheet. Okay. And then I've got the rules right here. When it's a 90 degree, you flip your X's and Y's, and then you match the signs to the destination quadrant. We want to talk about destination quadrant. That's kind of what these labels are, right? I've got quadrant 1, 2, 3, and 4. And they've got these signs right here, right? So this represents whether the X and Y are positive in that quadrant, right? So in here, they're both positive, and here your X is positive, your Y is negative, okay, and so on. So if we're going to do a 90 degree clockwise rotation, clockwise goes this way, clockwise goes this way. So I take this shape and I go this way. So 90 degrees is basically 1 box of movement. So I know it's going to be in quadrant 3. So I know that I'm matching the signs to the destination quadrant. I know both my X and Y are going to be negatives, okay? And so for a 90 degree, okay, I flip-flop my X and Y. So I've got 4 and -1. I switch those around, and I make them both negative. So B prime becomes -1, -4, okay? I flip these around, and they make them both negative. So -1, -1, and then -5, -1 for D prime after I switch them around and make them both negative. And now that I've got that done, I actually, plot these points. Start at the middle. My first is always X because it's on my X-axis, right? So I find -1, I find -4, which is right here, and I see where they meet. I'll label that as B prime. C prime is -1, -1 right there. D prime is -5 out here, -1 down here, so they meet right there. So that's D prime. And now I will connect my dots right there. And I can see, right, so B is kind of like pointing right, and so when I rotate it, it rotates over, it should be pointing down. I mean, looks good, looks congruent to me. Yeah. And so when you have a rotation that's already happened, you kind of got to figure out 2 things. You've got to figure out the degree or the distance that it moved, and you've got to figure out the direction. So you need two things. Oh, rotation. Let's combine a rotation, or let's define a rotation. Define a rotation is just when you turn a shape around a point called the center of rotation. For all the rotations we've done, it's the origin, right? So I've got right there. Okay. So when you turn a shape around the center of rotation, and you talk about you need distance, or you need degree of rotation. So 90, 180, or 270, and direction. Sorry, I'm trouble spelling this early. So clockwise or counterclockwise. Okay. All right. So we've got this one right here. I can see some people get confused when your shape kind of moves into different quadrants. So like the original shape right here, our pre-image is in quadrant 4 and quadrant 1. So it can be kind of hard to like distinguish like what's actually happening. If that's you, focus on one point. Okay. So if I focus on like J right here and J prime, okay, I can see that it's moved from quadrant 4 to quadrant 1. So that's one box of movement if I go counterclockwise, or it's 1, 2, 3 boxes of movement if I go clockwise. So there's two possible answers for this. You can say either there's a rotation 90 degrees, what did I say, counterclockwise, or 270 clockwise. I would accept either of those. They're both correct. Okay, because just from this figure right here, you can't tell which direction it went. So either one is correct. Okay, yeah, that's kind of how rotations work. Sequence of transformations is just two or more transformations in a row. Okay, and that's all a sequence of transformations is, right? So we can either do them or we can figure out what happened. Okay, so two different types of problems. For kind of all these, they have two different types of problems. Right, either doing the transformation or seeing a transformation that has already happened and then telling what happened, basically. Okay, so we're going to perform the sequence of transformations, label each image with prime notation as appropriate. So what that means is we're going to have 3 different images because we're doing 3 different transformations, and we're going to label them with single prime notation, double prime notation, and triple prime notation. Okay. So let's see, translate 7 units right and 1 unit up. So I'm going to do that for each point. 1, 2, 3, 4. So that's B prime right there. D, I can see that D right there is kind of over 2 to the right and up 1, so I can do that. That way I don't have to like count for each point. And C is kind of 3 straight up from B. So right there for C prime. So that's my first one right there. Okay, and then kind of just looking back and forth, I can see that they're both congruent to each other, so that's good. Now the idea is we're going to rotate 180 degrees clockwise. So my recommendation here for the rotation is you write down the points. B prime is 3, -4. Okay, and then C prime is 3, -1. And then D prime is 5, -3. Okay, and so 180 degree clockwise rotation, technically it doesn't matter which direction you go because you would get in the same spot, you would end up in quadrant 2. But for a 180 degree clockwise, you keep your X and Y in the same order, right? You don't change the order, you just match the signs to the destination quadrant. Now, that's negative positive. Okay, I know it's going to end up in quadrant 2. So all that happens here is I take B double prime, and I say -3, -4, C double prime, -3, -1, and then D double prime, -5, -3. And then I graph those points. So it's kind of a lot of work to do kind of like these sequences, right? But yeah, it's kind of a lot of work. Actually, my bad here. This is positive, positive, positive. Sorry, guys, I was screwing up there. -3, +4, so we go left 3, up 4. That's B prime. -3, +1 is right here for C prime, and then D prime is -5, +3. Okay, so now I'm going to connect my points here. And I can see like D prime is pointing this way, so as it does rotation, D prime points that way. So, okay, cool. So that's, we've done that one, we've done that one. I'm actually going to get a different color for the third one. And we'll see if purple shows up. Okay, so we're going to reflect over the y-axis. Now the y-axis again is the vertical axis, right? And so what we do, and you'll notice, guys, I am doing the subsequent transformations from the new image, right? So I didn't rotate this guy counterclock, or I didn't rotate this 180 degree clockwise. I rotated this one 180 degree clockwise. So when I reflect over the y-axis, I'm going to rotate this one and reflect it over the y-axis, okay? So I've got B prime is 3 away, so B triple prime is right there. C, you know what I forgot to do? I forgot to do my double notation on there. C double prime is 3 away, so C triple prime is 3 away. And then D double prime is 5 away. So I count 5 on the other side right there for D triple prime. And that's that. I've performed 3 transformations and moved my shape around a lot. There you go. Okay. So this last one, we have a sequence of transformations that has happened. So we got to tell what's happening. The idea here is like, you can't do one transformation that will get this pre-image to this image, right? You can't translate it and do it. You can't reflect it. Well, you could technically do a reflection over a diagonal. I think that would do it, but we're not going to worry about that. And a rotation isn't going to get you in the right orientation for it. So the idea here, there's a couple things you can do. I think the best thing to do is do a rotation 90 degrees clockwise, and that'll basically put it, let's see, T would be right here, P would be right here, S would be right here, 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 right? And I could like go through the points and stuff and figure that out, but like that's not really necessarily what I'm looking at. And so P, after I rotate it right there, that's T, S, R becomes this one, and then Q becomes this one. Okay, so that's a rotation of 90 degrees clockwise. You could also do 270 counterclockwise, and that would get you in that right orientation right there, either one. And then I can see that like I've got my matching T's right here. They're each one away, or they're 2 away from each other, which means there's a point in the middle. Same thing with R, and so that line right there is the X axis for the reflection. Right? So then you would reflect, excuse me, my nose, I'm going to sneeze, over the Y axis. X axis, my bad, sorry. Yep. There you go, guys. That's your review.